Welcome to UGC lecture series in computer science. We are going to see a series of lectures in the subject operating system. This subject is for the students who are studying in the 5th semester of their BSc degree program. So this is of paper number 8. In today's session, we are going to see few topics from unit 1. So there are several topics in unit 1, out of which in today's session we are going to see the topic on CPU scheduling. So already we have dealt with two different lectures on CPU scheduling. So today's session will be the third lecture of the CPU scheduling. So we have already seen in this unit 1, we have already seen lectures on what is a CPU scheduling, what are the basic concepts in CPU scheduling, what do you mean by an IO burst time, what do you mean by a CPU burst time, what is the difference between IO burst and the CPU burst time, and then the different scheduling algorithms. There are 4 different algorithms which we have seen in our earlier sessions. So in today's session we will be seeing this CPU schedulers and different ways of scheduling the CPU. So as far as the today's contents of this program is concerned, we will be seeing topics on multi-level queue, multi-level feedback queue, multiple processor scheduling, multi-core processor scheduling, and the difference between a multiple process scheduling and the multi-core process scheduling, thread scheduling, Pthread scheduling, which is otherwise called as POSIX thread scheduling, wherein in our previous session we have already seen the topic on POSIX threads. What is a POSIX thread and how it is being used? POSIX thread is, I suppose you might be remembering, the POSIX thread is one that has been used in the Unix operating system. So the Unix operating system, it automatically creates a signal, and you have a signal handling. Supposing if any sort of event happens, so the signal handling intimates it. So this POSIX thread is related to the Unix operating system. So we will be seeing a few topic on, we will be seeing the contents about the how this POSIX Pthread has been scheduled, and then we will be seeing one other topic on Windows scheduling. What is a Windows scheduling? How the CPU is scheduling this Windows operating system. So now, what is a multi-level queue? What do you mean by a queue? In our previous session, in our earlier lecture, we gave you a topic on different types of scheduling algorithms. There are 4 different types of scheduling algorithm. One was called as FCFS, which is otherwise called as first come first served algorithm, and the second algorithm is called as a shortest job first, which is also known as SJF algorithm. The third algorithm is called as the priority scheduling algorithm, wherein you do not have any sort of shorthand forms, like as you have said, like the FCFS and SJF. And the fourth scheduling algorithm, we call it as a round robin algorithm, or it is otherwise called as an RR algorithm. Now, what was the FCFS algorithm state? The FCFS algorithm states that whatever, if the process is going to come first, then it will be served first. So it is a first come and first served basis. What is an SJF algorithm state? The SJF algorithm states that the shortest job, that is a process which gets executed at the shortest period of time, will be taken first and it will get its execution, and then that will be considered as the first process and the algorithm will be scheduled accordingly. So such a job we call it as the shortest job first algorithm. The third type of scheduling algorithm wherein we saw is the priority scheduling, wherein we need to prioritize certain things and then we need to schedule it. I suppose I gave you an example. You might be remembering an example as supposing if you are going to have a party, a function, and for that function, if a particular chief minister of the state is going to come and the ministers of the state is going to come, and then the MLAs of that particular state is going to come, and then the press media as well, the audience is going to come, to whom you will be giving your priority. Hopefully, definitely you will be giving the first priority to the chief minister of the state, and then to the ministers of the state, and then the third priority will be given to the MLAs of the state. The fourth priority will be given to the press and media people. The fifth priority will be given to the audience. So likewise, you are prioritizing certain things. So based on the priority of the execution of the process, this priority scheduling has been done. So this was seen earlier and then in the earlier session. And then about the next algorithm was about the round robin algorithm. In the round robin algorithm, wherein it works with a time quantum. What do you mean by time quantum? The CPU, it will be allocating one specific time quantum. Say for example, if it is going to allocate somewhere around 4 milliseconds, and if your process 1 takes 24 milliseconds of a burst time, then process 2 takes 3 milliseconds to complete, process 3 takes 3 milliseconds to complete. Then for 24 milliseconds, the CPU has not allocated a time frame, time quantum, wherein it has allocated only 4 milliseconds. So for the first 4 milliseconds, the process 1 will get executed. So the process 1 has been left out with the 20 milliseconds of its time. So the process 2 then, which is there in the queue, will make its execution. So it will complete its execution in 3 milliseconds of time, wherein 1 millisecond has been left out free from the time quantum. And process 3 also executes in the same fashion of 3 milliseconds, wherein 1 millisecond has been left out. And the remaining time frame, the remaining 20 milliseconds are available in the process P1. So it comes to the backside of the P3 and then it gets executed. So for executing 20 milliseconds, since only 4 milliseconds of its time quantum has been allowed, so what has to be done is the time quantum, the 20 has to be divided into equal parts. So 20 divided by 4 is 5 different time quantums. In 5 different time quantums, this process P1 will get executed. That is a round robin approach. So now we will see the round robin approach and we will see how this round robin approach gets implemented in a multi-level queue system. So what do you mean by a multi-level queue? From the name implies, what can you infer from this title multi-level queue? This multi-level queue is like there will be a set of processes. Say for example, there are 4 different processes wherein which is waiting for the printer resource, the I/O resource, the printer resource. There are 2 different processes which is waiting for the CPU resource, some sort of computational resource. Then how does it work out? What happens here is all the 4 processes, whichever is waiting for the I/O devices, will be put on one particular queue. Whichever is waiting for a printer will be put on one separate queue. Supposing if the processor is waiting for some sort of scanning device or some sort of, if it is going to wait for a projector device, then that scanning device will be put, that is a processor which is waiting for the scanner, will be put on a separate queue. Then the process, supposing if there are 2 processors which are waiting for the computational resource, then those computational resource processor will be put on a separate queue. Then what happens here? Everything has been segregated into different queues, and then the processing takes place. But what is the major drawback or what is the disadvantage of this? You have a very limited main memory. The main memory, I suppose you might be knowing, the memory is being classified into 2 types. One is a main memory and the other one is a secondary memory. What is a main memory? The main memory is the RAM memory, random access memory, and the secondary memory is the hard disk memory. The main memory is pretty faster, much more faster when compared to the secondary memory. So in this case, you have say for example, you are going to purchase a computer wherein in your computer you have an hard disk size of 500 GB and consider the RAM size, you have put it as 2 GB DDR2 RAM. So for the 500 GB of hard disk, which is said to be a secondary memory, your RAM size, your main memory size is only 2 GB. Wherein when you are going to schedule, when you are going to line up all these processes in a queue for based on the different devices or based on different levels of getting the inputs, then when all these processes occupy all the 2 GB of the RAM space, then there will not be any space for computation. That is a drawback. Our main memory usage itself is to make maximum computations possible, to make the execution to get completed in a faster place. But when you are going to queue it in such a way, then definitely we will not be in a position to execute it at a faster pace. So that is a major drawback in using a multi-level queue. But what is an advantage of it? You are able to segregate all these portions of the processor, whether it is going to go for an execution, whether it is going to go for a printer, whether it is going to go for a console unit. What is a console? A console is any output device, you call it as a console. To whether it is going to go for a monitor, whether it is going to be used for the computational purposes. So you are in a position to segregate the contents, but you are not in a position to but the speed or the efficiency level decreases in this multi-level queue. So this multi-level queue is of two, it has been partitioned into separate queues. One is called the foreground queue, other one is called the background queue. The foreground queue is said to be an interactive queue, background queue is said to be the batch queue. I suppose we have given certain valid discussions on this foreground queue and the background queue in our earlier session. A foreground queue is one which is interactive, means which is something like an online. I gave you an example with respect to an ATM counter, wherein if you want to withdraw some money, withdraw somewhere around 10,000 rupees, you type in the input as 10,000, and the server will be checking whether there is sufficient balance in your account. Supposing if there is a balance, it will be giving you the money of 10,000. And supposing if I gave you this example with respect to a rumor that has been spread in the banks, supposing if the bank says that if you are going to get a rumor stating that particular bank is going to get closed by midnight, by tonight. So what happens here is, if that is the case, n number of people will be using that particular CPU, particular server. So what happens in this case? All the servers, when more than the stipulated number of resources being used, when more than the stipulated number of processors are being called, then definitely the server becomes slow. So when you are going to arrange all these people in the queues, then definitely there will be a slag. So that is called as a foreground multi-level queue or an interactive queue. For the batch queue, I gave you an example with respect to the printer system. After banking hours, all the schedules will be printed out. That is a batch queue. And this foreground queue uses an algorithm called as a round robin approach. And this background queue uses an approach called the FCFS approach. And this multi-level queue scheduling is being done with two different types of scheduling. One is called as a fixed priority scheduling, other one is about time slice. In the case of a fixed priority scheduling, it results in the possibility of starvation. What do you mean by starvation? Starvation is, supposing if it is going to serve all from the foreground, then from the background. Supposing if all the front end screens alone is being served, you type in as 10,000 rupees, and at times you would have noticed in the ATM counters that you will be waiting in the ATM counter for a pretty longer period in order to get the money from the ATM machine. It is because you have been put on a queue. At the same instance of time, someone else from a different branch of the ATM counter will be using this withdrawal section, and so for each and every one, this server has to respond to their request, and that is the reason you may be put on a queue. So that is called as a fixed priority scheduling. For the server, all are said to be customers, so each and every one will be put on a fixed scheduling. This time slice, what will it be doing? This time slice, each queue gets a certain amount of CPU time which it can schedule among its processors. That is 80% to the foreground and 20% in the background. I said for the foreground approach, you are going to use an RR approach, RR scheduling. RR is round robin. For the background, you are going to use the FCFS. FCFS is the first come first served approach. So here time slice is nothing but certain specific time frame has been allocated to this process. That is called as a time slice. So for each and every process, so if I'm going to first of all how it has been prioritized, first we need to get the input from the user. So we are getting as much of input from the user like 10,000 or 5,000 or 2,000, whatever the input is going to give, we are going to get it out. So what happens actually is, we will not be in a after giving the input of 10,000, 5,000, 2,000, you are given it to the bank. It is a server who has to respond and give the money back. So for giving the money back, it can take a specific amount of time. But for taking the input from the customer, it has to be in a hurry. Then only it can take as much of input, and then it is your fate that you need to wait in the system in order to get the money from the ATM machine. So that is a multi-level queue. And then let us see a diagrammatic representation of multi-level queue, how it has been prioritized. Here the system process has been given the highest priority, then interactive processes, then interactive editing processes, then comes the batch process, then comes the student process. What do you mean by system process? A system process is one which has been done with the kernel itself. The interactive process is one which has been done in the ATM machine. The interactive editing process is one which has been done in the ATM machine. Supposing we are going to type in 10,000 and it will be asking you whether it is correct or wrong. When you say it is incorrect or wrong, you will be prompted again with the input. That is called interactive editing process. Then you have the batch process, how it gets performed at the background. And then you have a student process, wherein you generate all sort of reports. After printing, you get a mini statement or so, or the statement print will be done. So that is an example of a multi-level queue. Now let us see what is a multi-level feedback queue. In the case of multi-level feedback queue, we have various queue schedulers. It requires the following parameters. One is the number of queues. The second is the scheduling algorithm that is required to perform in each and every queue. I suppose I said that all the process will be allocated, will be lined up, will be queued up with respect to its own request. That is, if a processor is going to request for an IO device, it will be lined up in a separate queue. If the processor is going to request for a computation, it will be lined up in a separate queue. If the processor is going to request for any other console device, it will be lined up in a separate queue. So this has been lined up. Now the multi-level feedback queue has to schedule an algorithm for each and every lineup. For each and every separate lines of queue, it has to schedule an algorithm. The next point over here is the method used to determine when to upgrade a process and the method used to determine when to demote a process. What do you mean by demote? First you are going to upgrade, then you are going to demote. You are going to withdraw the process. Then the method used to determine which queue a process will enter when that process needs a service. So these are the parameters that are required for a multi-level feedback queue. Then let us consider an example for a multi-level feedback queue. So let us consider there are 2 or 3 number of queues. So the example is here over here. Let us consider there are 3 different queues. One is Q0, other one is Q1, the other one is Q2. Wherein this Q0 uses a round robin approach with time quantum of 8 milliseconds. That is, Q1 has again the round robin time quantum of 16 milliseconds. And Q2 uses this FCFS, first come first served approach. So now we have a new job that enters Q0, which is served with FCFS. So when it gains the CPU, the job receives 8 milliseconds. So if it does not finish in 8 milliseconds, what does this 8 milliseconds denote? Here in this queue, the quantum time was 8 milliseconds. The time allocated by the CPU is only 8 milliseconds. Whereas in Q1, the time allocated is 16 milliseconds. So here if it is not able to complete in 8 milliseconds, this particular process will be moved back to that Q1 after all the other processes gets completed. That is called as a quantum time. So this will get, if it is not able to get completed, it will move after all the other processes. So that is called a quantum time. Then at Q1, this job is again served with FCFS and receives 16 additional milliseconds. In this problem, here Q0 has only 8 quantum milliseconds, wherein Q1 has 16 quantum milliseconds. So even if it is not able to complete, if the process is not able to complete it with 16 milliseconds, then it has to go to the queue again. Say for example, you have 25 milliseconds. You say that it will take 25 milliseconds to complete a particular process. But I have been allocated only 16 milliseconds. Then what will I do? Will I be coming out of the process? No, definitely not. I will come backside of the all other waiting processes, and then I will be standing at the back. Then I will see to that I am able to fulfill the remaining set of resources. So I am able to complete the remaining set of processes. So likewise this works, and this is called as a multi-level feedback queue. So we will see this example on a diagrammatic basis. So it has been given here. So say for example, this Q0 has been allocated a time frame of 8. Then if it is not able to complete, it comes over here wherein this Q1 which has been allocated a time frame of 16. If it gets completed, then it automatically goes out of the loop. Even here, if it gets completed, it automatically goes out of the loop. If it is not able to get completed, then it goes to this FCFS. FCFS is the first come first served algorithm, which we have seen in our previous sessions about the Gantt chart, and then how to find the average time using an FCFS approach. So based on that, this FCFS approach will be working. So this is what a multi-level feedback queue example is. Then let us see the next topic as multiple processes scheduling. What do you mean by multiple process scheduling? And our next topic will be as multi-core process scheduling. Now what do you mean by multiple processor and multi-core processor? A multiple processor is, from the name implies, 2 or more processors are available. So we are going to schedule an algorithm. We are going to schedule, the CPU is going to schedule for the 2 or more number of processors. So far whatever we have seen is with respect to a single processor. Something like working with Pentium machines, Pentium 1, Pentium 2, Pentium 3, Pentium 4. Those things we have only single processor. Wherein multiple processors is 2 processors. At a simultaneously you have 2 different processors and working with 2 different processors. So what is the advantage of using 2 processors? The efficiency time will be more, the impact will be more, the computation speed will be much more faster when compared to using a single processor. Say for example, if you have a task, and if there is only one person to complete the entire task, he will take, consider he is going to take 6 days of time. Supposing if there are 2 people who are willing to complete the same task, who are equally brilliant enough, then it will take 3 days to complete the same old task. So that is the advantage of using a multiple processor. So this multiple processor, the computing, the scheduling will be of 2 types. One is called as the homogeneous processors and the other one is called as asymmetric multiple processing. A homogeneous processor is a processor that has been kept within a multiple processor. Asymmetric multiple processing is only one processor that can access the system data structure, alleviating the need for data sharing. Now, what is a multi-core process scheduling? Multi-core is, I suppose you might be knowing about you would have experience working with a dual core processor, a core 2 duo processor, a quad core processor. Core 2 duo is wherein you have 2 processors. So it is multi-core. It is not single, you have 2 processors. And what is a quad core? You have 4 processors. So working with core 2 duo or quad processor, then it is even more faster when compared to all other processors. So that is called as a multi-core process scheduling. So this multi-core process scheduling is of two types again. So this can be scheduled in two different ways. One is symmetric multiprocessing and the other is the processor affinity. Symmetric multiprocessing is each processor is self-scheduling. All processors has its own private queue of ready processors. And processor affinity is, it's of two types. One is soft affinity and other is the hard affinity. What is a soft affinity? Soft affinity is nothing but like it is supposing the processor is computing and supposing if you are going to interrupt a process, it will get interrupted one and only after saving the contents in the PCB. PCB we have seen in our earlier sessions, process control block. Hard affinity is supposing if an interrupt comes in and forcibly pulling the process thread and closing it is called the hard affinity. So like without saving the contents. Then next topic is about the thread scheduling. What is a thread scheduling? A thread scheduling is, it is a distinction between a user level scheduling, user level thread and kernel level thread. In our previous session, we have seen about the user level thread and kernel level thread. What is a user level thread? A thread that has been created by the user and which has been managed by the user is called as a user level thread. A kernel level thread is a thread that has been created by the operating system, wherein you will not be given the permission to create a kernel level thread once the operating system has been booted. So you can create as many user level threads as possible. You can delete, you can manipulate, you can manage, but creating a kernel level thread is not possible after booting the operating system. So the managing or mapping between the user level thread and the kernel level thread and scheduling an algorithm, scheduling the CPU for this is called as a thread scheduling. Then this thread scheduling is also known as process contention scope, since the scheduling computation is within the process and it is typically done via priority. Then the next one is about a Pthread scheduling. What is a Pthread scheduling? Pthread scheduling is one which is being used with a POSIX thread scheduling. So POSIX thread scheduling is one wherein we use it in our Unix operating system. So we have seen about the POSIX threads and all in our previous session. So we are not giving more explanation on this POSIX thread. So this is one type of scheduling. Then the next type of scheduling is the Windows scheduling. What is a Windows scheduling? How it has been scheduled in the Windows? Windows also uses a priority based preemptive scheduling. The highest priority threads runs as the next level. Then you have a dispatcher. What is a dispatcher? I gave you an example with respect to a post office wherein you have two or more number of letters have been coming in and how the postman segregates and how it has been dispatched to the end user. Likewise, here this dispatcher works in. So you can compare this example with respect to the example that we have seen in our earlier session. Then this Windows scheduling, real-time threads can preempt non-real system. It is a 32 level priority scheme. And then this variable class is from 1 to 15 and real-time class is from 16 to 31. So if there is no runnable thread, then it runs an idle thread. So this is about a Windows scheduling. Then we will see about this Windows priority classes. Here the base priority is said to be normal within the class. If the quantum expires, priority gets lowered but never below the base level. If wait occurs, priority boosted depending on what it was waiting for a particular process. Now let us summarize whatever we have seen in this session. We have learnt about the multi-level feedback queue scheduling. We have seen about the multiple processor scheduling and multi-core processor scheduling. We have seen the difference between a multiple process scheduling and a multi-core process scheduling. And then we have studied about this thread scheduling as well. I gave you a detailed look on this Pthread scheduling. we have also studied about the Windows scheduling and how it has been used in this Windows operating system. Now, let us see the possible questions that can arise from this session. Question number 1. What is a multi-level queue? What is multiple processor scheduling is? Or what a multiple process scheduling is? What is a multi-core process scheduling? What is thread scheduling? Define Pthread scheduling or the POSIX thread scheduling. What is Windows scheduling? So these are the questions that are possible from this session. So with this, we come to an end of this session. So we can see forthcoming in our forthcoming sessions, we can see more topics on operating system. Thank you.